Alright, today we're going to talk about air pollution, and first of all, let's begin with some concepts and terminologies in this topic. What is air pollution? To define air pollution, first we need to see what is perfect clean air. If we use filtration and some other sophisticated method to remove air contaminants like dust, dirt, smoke, pollen, microbes, chemicals, then we end up with nitrogen almost 70%, 75%, oxygen almost 23%, argon less than 1%, carbon dioxide almost 0.03%, and other gases and water vapor in a lesser amounts. These percentages are actually weights. That's the definition of the perfectly clean air. And as you can see, almost 99% of perfect clean air consists of nitrogen and oxygen. In reality, there is no perfectly clean air. There are always chemicals not found in perfectly clean air. But under laboratory condition, it is possible to produce perfect clean air artificially using filtration and other techniques. Now, based on the definition of perfect clean air, we can define air pollution. Air pollution refers to the presence of substances not found in the perfectly clean air, like suspended particles, vapors, dust, chemicals, dirts, and so on. The next concept in air pollution is smog, and smog simply means smoke plus fog. And the smog is a combination or mixture of pollutants, particularly ground ozone, nitrogen oxide, carbon monoxide, particulate matter, and others. We will talk about pollutants one by one in the next few slides. A major reason for smog are due to burning petroleum fuels such as gasoline, car exhaust, especially in heavy traffic, and sunshine, high temperature, calm wind, and temperature inversion. These are the main sources that create a smog, and in this picture you can see an example of a smog. Air pollution can adversely impact the environment. It can damage natural environment and also built environment. Natural environment such as forest, lake, wildlife, soil, or national parks such as Grand Canyon. And this picture shows Sequoia National Park in California. You can compare the same view on a bad day of air pollution and also on a good day. Air pollution can also damage the built environment, such as historical buildings and structures. Air pollution can adversely impact human and animal health. The effects can be short or acute impact, low-level exposure to air pollution can cause wheezing, coughing, nausea, and headache, irritation of eyes and nose and throat, and some respiratory diseases such as bronchitis and pneumonia. On the other hand, high level of exposure to air pollution can cause long-term effect damage to vital organs like the nervous system and lungs. It can cause some forms of cancer like lung cancer and skin cancer, because depletion of ozone can cause skin cancer. And heavy episode of air pollution can kill people, especially vulnerable groups like elderly and children. Let's talk about some of the important respiratory diseases that are associated with air pollution. The first one is coronary heart disease, or CHD. Air pollution causes serious damages to the cardiovascular system. Coronary heart disease is the result of narrowing coronary arteries. So arteries are large blood vessels that provide blood and oxygen to heart. So this picture shows us a normal coronary artery, and here is a narrowed coronary artery because of particles in air pollution, cigarette smoking, car exhaust. So you can see lower amount of blood and oxygen can enter heart for this picture. So, and it can even block the vessel, so which may lead to heart attack. Coronary heart disease affects 7 million Americans every year, and each year almost 500,000 people die because of the heart attack. The next respiratory disease is asthma. Asthma is a chronic disease, which means that it persists for a long term. The picture on the left shows the normal airway, and this one is for a patient who has asthma. You can see that the inside walls of the patient with asthma of the airways are inflamed, and this inflammation makes the airways sensitive to things like that are allergic or things that cause irritation. So you can see airways get narrower and less air can goes inside the lungs of the patients. So breathing becomes more difficult and can cause some other symptoms like constant coughing or constant wheezing. Asthma is one of the most frequent chronic diseases in the United States. Its prevalence is being increased since 1980. Every day, on average, 14 Americans die because of asthma, which is 3 times greater than 20 years ago. And studies have shown that children in New York City are twice more likely to be hospitalized than national average because of asthma, which is closely related to air pollution. Other factors that can have an effect on asthma are smoke cigarettes or constant second-hand smoking, genetic factors. For example, if someone in your family has asthma, you are more likely to have asthma as well. Lung cancer is another health effect associated with air pollution. First, let's see what is cancer. So when cells in human body die, they are normally replaced by new cells. That's the normal situation. Okay, but cancer cells don't die. They divide and they grow out of control, and they form tumors, and they spread to the other organs through bloodstream. So in lung cancer, the cells divide and grow in lungs and form tumors like this and this. In this picture, you can see healthy lungs on the left, earliest stage of cancer, and then latest stage lung cancer. Notice cells in the lungs that grow out of control here in the earliest stage and in the latest stage. And air pollution is a suspected cause of lung cancer, suggesting that it is associated with lung cancer. It can make the situation worse, but it is not for sure the main reason for lung cancer. Where does Ohio stand in terms of rate of lung disease in United States? According to Center for Disease Control and Prevention, CDC, the rate of lung disease and bronchitis in Ohio in the year 2016 for all ages, gender, and races between 64.9 and 86.8, which places Ohio among the states with very high rates of lung disease. Who are susceptible group to air pollution? Elderly people with ages over 65, and children because their lungs are still growing, and people with chronic diseases are at higher risk of air pollution. And children exposed to air pollution may develop asthma, lung disease, and chronic cough and respiratory irritation in future. Previous researchers have shown that air pollution can be associated with socioeconomic factors. People in poverty, people with low access to healthcare, people with no education level had higher incidence of respiratory diseases, or people with pre-existing conditions such as diabetes. So you can investigate the effect of socioeconomic factors on the respiratory diseases for your final project. Some of the notorious episodes of air pollution in the history are in the Meuse Valley in Belgium in the year 1930. In only 2 days, more than 60 people died because of episode of air pollution or heavy air pollution. In London, England, in the mid-20th century, almost 4,000 people died because of smog which is mixture of pollutants. And in the United States, in the mid-20th century, 4 years before London disaster, in Donora in Pennsylvania, air pollution episodes happened. And Donora town is located 30 miles south of Pittsburgh and is the home to many industries like steel and zinc plants. The disaster happened in only 5 days, from October 27 to October 30 in 1952, and killed 20 people and caused chronic respiratory problems to almost 6,000 people out of 14,000 residents of the town. This disaster is considered as one of the worst air pollution disaster in history because of the topological characteristics of Donora, which is surrounded by mountains. Air pollution or smog was trapped for 5 straight days and couldn't disperse to other areas to have less effects, and killed some people, especially elderly, and caused respiratory issues to almost half of the residents. Now let's move on to the next module, major sources and components of air pollution. Sources of air pollution can be divided into 2 categories. Natural sources like dust, smoke, and ash from volcanic eruption. For example, this picture is for a volcano eruption in Washington in 1980, which emitted tons of fine ash and covered a wide geographic area across so many states of the United States. Another natural source of air pollution is forest fire. Usually starts with lightning strike and emits a huge amount of smoke and ash into the atmosphere. And another natural source is wind storm that spreads dust, dirt, pollen, salt, and other organic material from plant to the atmosphere. The second source of air pollution are anthropogenic sources, meaning that they result from human activities. Anthropogenic sources can be stationary, like oil refineries and chemical plants, and electrical generating plants, and of course incinerators, which we are familiar with them from solid waste management lecture, that could contain hazardous material like heavy metals. Another anthropogenic source is mobile sources. They can be divided into on-road vehicles, off-road vehicles that can cause air pollution in national parks and wilderness areas, and non-road vehicles like airplanes and trains. So these are the sources of air pollution resulting from human activities. The components of air pollution can be divided into 2 categories: primary components and secondary components. Primary components are directly emitted to the environment from the sources of air pollution. Examples are carbon monoxide, ozone, nitrogen dioxide, and sulfur dioxide. And secondary components are generated from chemical reactions among primary components. An example of secondary component is production of smog. We will talk about each component one by one. An important term you may see in the literature is criteria air pollutant. It is established by EPA, Environmental Protection Agency, to describe a group of very common pollutants which have known impacts on health and environment. So there are 6 criteria air pollutants, including ground ozone or O3, fine particulate matter PM2.5, nitrogen dioxide or nitrogen oxide, NO in general, carbon monoxide, CO, and sulfur dioxide, SO2, and finally lead. Let's start with ozone. Ozone is a special form of oxygen made up of 3 oxygen atoms. It is colorless but has pungent odor and can spark from electric equipment. Ozone can be good or bad for our health. Good ozone occurs up here, this part. and it's about 20 to 30 miles above Earth's surface, and protects the Earth from the harmful UV rays of sun. But good ozone has been damaged because of human activities, in particular CFC production, which already was extensively used in air conditioners and refrigerators, and now its production has been restricted. And bad ozone is near the Earth's surface, and inhaling ground ozone, so it is also called ground ozone. Inhaling ground ozone can cause damages to the lungs and respiratory tracts and eyes, and also can cause damages to environment, particularly to the forest, plants, and animals. The second criteria air pollution is NO, nitrogen dioxide or nitrogen oxide. Nitrogen oxide and nitrogen dioxide is produced from burning fuels, including gasoline and coals. It is also can be found in tobacco, in cigarettes. So NO is a major component of acid rain that we will talk about in the next few slides. And health effects associated with nitrogen oxide are nose and throat irritation, and also increased respiratory infection. In the lab, you will see we can obtain each of these criteria air pollutants from EPA website, and then we can investigate the association with the health outcome. The next criteria air pollutant is carbon monoxide, which is a colorless, odorless gas and extremely poisonous. It can kill animal and human in minutes of exposure. That's why it is also known as silent killer, no odor, no smell. Carbon monoxide is produced by incomplete burning of fuels in all forms, gas, solid, or liquid fuel. Burning charcoal and also leakage in gas refrigerator can produce CO. It should be noted that tobacco in cigarette can produce CO, but the level of exposure is not sufficient to kill people. But inhaling high level of CO can aggravate CHD or chronic heart diseases. Circulatory and respiratory diseases also can be affected. And this is because when high level of CO enters your body replaces the CO with oxygen in red blood cell and prevent the blood from getting oxygen. The famous disaster because of high level of exposure to CO happened in West Virginia mines. The first one in the year 2006 in Sago mine killed 15 people, and the second one in the year 2010 in another mine, Upper Big Branch, killed 29 men. The next criteria air pollutant is PM or particulate matter, which includes both solid and liquid particles suspended in the air, such as dust, pollen, smoke, dirt, soot, and liquid droplets. The major sources of particles are car exhaust from trucks and buses, smokes from incinerating garbage, so they may contain heavy metals and can be very dangerous. Burning woods and industrial activities are also a major source of PM, particulate matter. PM can be very dangerous and can be linked to lung damages, bronchitis, and early mortality. This figure shows us the size of particulate matter. This is human hair with a diameter of 50 to 70 micrometer, and PM can be either 10 micrometer or it can be 2.5 micrometer. And 5 times for the 10 micrometer, it is 5 times shorter than diameter of human hair, and PM 2.5 is almost 25 times smaller than the size of the diameter of the hairs, and they are very, very small in diameter and very dangerous. So again, PM 2.5 are very small and are invisible particles with 2.5 micrometers or less. They are very dangerous because when inhaled, the hair in the nose cannot catch the PM 2.5, and they get deep down human lungs and deposit there. If they do not dissolve, your body is not able to remove them efficiently. Some Researchers have claimed that PM 2.5 is associated with almost 60,000 smog related deaths annually in the United States. The next criteria air pollutant is sulfur dioxide. Sulfur dioxide is a gas that is produced by burning fuel and that contains sulfur. An example is coal. Sources of sulfur dioxide are power plants that use coal, particularly when there is no efficient emission control of sulfur dioxide. Some industries like production of paper and melting metal, they can also produce SO2, and SO2 is another major component in acid rain. The other one was nitrogen dioxide, if you remember. So this map shows the geographic distribution of sulfur dioxide. You can see it is restricted to eastern part of the US because there are more industrialization there. One of the consequences of air pollution is acid rain. Acid rain occurs when sulfur dioxide and nitrogen dioxide are emitted into the atmosphere. They then will react with water and oxygen and form sulfuric acid and nitric acid. And with rainfall and snow, they will settle on the ground, which also known as acid rain. So what are the effects of acid rain? They can have huge adverse impacts on the human health and also the environment, both the natural environment such as wildlife and also built environments such as buildings. Acid rain can change the pH level in soils and then enters the food web. So these are some consequences of acid rain on wildlife and also on the structure and also the forest. Another consequence of air pollution is temperature inversion. In normal situation, warm weather is near to the ground, and as we move upward in the atmosphere, the temperature consistently decreases. That's the normal situation. But sometimes due to the adverse environmental or topographical conditions, temperature inversion occurs. So here we have temperature inversion. And this is because pollutant or smog are built up and are trapped close to the ground, and warmer air layer acts like a cap and holds this smog near the surface of the earth. Warm air is above the cooler air, so that's the temperature inversion. But above this warm layer, again, as we move up in the atmosphere, the temperature decreases. So that's the temperature inversion. And temperature inversion is a serious problem in Los Angeles because of the topography characteristic and prevailing winds. In this city, the coastal winds push pollutant away from their sources, but the smog or pollutants cannot escape and is stopped because of the nearby mountains, making a higher concentration of the smog near to the ground. And this layer of pollutant can trap under the warm layer and cause a health problem to the environment and also to the human.